All right, the second part to the objective three notes, very similar to the first part. In fact, it almost looks a little repetitive in some parts, but this does have some different types of examples. In 3.3a, we only had graphs that pass through. Now we're going to see some that bounce, and the questions are asked differently on the second page. So kind of a lot of examples, but we got to make sure everything's covered here. All right, so write an equation which describes the polynomial graph shown below. So we can go through the first couple kind of quickly here. So if I want to write an equation for this thing, well, I know it's got to have y equals in it, so that I can start there. Let's see, my end behavior is high to high. So what type of leading coefficient do I have to have there? Well, any positive number will work, so we'll just go with like a 3. But again, any positive number will work. Positive 1 works, which you don't even need to write. And then I got 1, 2, 3 x-intercepts, which means I'm going to have 3 factors in my equation. To get an x-intercept at -4, I got to have x plus 4. It passes through, so then it's to the first power. Here, to get an x-intercept at +2, I got to have x minus 2. And since it bounces there, well, then I know that has to have a multiplicity of 2. Technically, any even multiplicity, but we're going to stick with 2. And then to get a x-intercept at +5, I got to have x minus 5 as a factor. And since it passes through, we're going to leave it to the first power. So then there's my equation. So the only main thing that we didn't see on 3.3a notes is we didn't have anything with a multiplicity of 2. So again, anytime it bounces, we need to make sure that it's squared. Okay? All right, let's do it for this one as well. So if we want to write the equation, well, first of all, we need y equals, so we'll start with that. Next, my end behavior is low to high. Okay, so that tells me two things. I know it's going to be an odd degree, and low to high, it's going to be a positive leading coefficient. So again, I can stick with +1, or let's put something we can actually see, like how about a 4? Okay, and then next, what are my factors going to be? Well, to get an intercept at -5, I got to have x plus 5. And then, well, let's be careful. Since it bounces here, that means that it has to be raised to an even degree. So it has to have a multiplicity of 2 or 4 or 6 or whatever. But again, we're just going to stick with 2. And then next, to get a intercept at +1, we got to have x minus 1. It bounces there, so that also has to be squared. And then to get an intercept at +4, we got to have x minus 4. That one goes through, so it's an odd multiplicity, so we'll leave it with a power of 1. And then there's my equation. So again, I can change this to a different positive number. It can even be a fraction or whatever, but as long as it's a positive number, then this works. Okay? Moving right along. Next, these ones that we know take a little bit more work. Write the equation for the polynomial graph shown. Okay, so first of all, this one kind of walks us through how to do this one. List the factors which create the zeros. Okay, so let's see. I got to have x plus 2 to get an intercept of -2. I got to have x minus 1 to get an intercept at +1, and I got to have x minus 4 to get an intercept at +4. All right, next solve for the a value by using the other point they gave us, which the y-intercept they gave us is the point 0, -6. Okay, so they didn't lay it out well for us here, but we know our equation is going to be y equals that stuff times some a value. Okay. Also, since it's high to low, I know that a value should be a negative number. Okay, and then what negative numbers are going to be? Well, let's stick in x is 0 and y is 6. We can probably squeeze it in right here. So if y is -6, when x is 0, we get -6 equals a times, then if I stick in 0 here, here, and here, I get 2 times -1 times -4. Okay. Let's see, multiply these out, we get +4, +8, so -6 equals 8a. So then that means a equals, when we divide both sides by 8, -3/4. Okay, and now rewrite the equation using that number. So we're going to put the -3/4 in right here, and we'll have our answer. So we get y equals -3/4 times x plus 2 times x minus 1 times x minus 4, and they all have a multiplicity of 1, so then that's our equation. Okay, so these can take a little bit of work, but nothing terrible. All right, moving right along. Okay, so again, write the equation for the polynomial graph shown. Okay, well, if I'm going to write the equation, I got to have an equal sign in there, so we'll start with y equals. I need to have some a value, which since my equation is high to high, I know it's going to be some positive number, times what factors? Well, my intercepts are at -3 and +2, so I got to have x plus 3 and x minus 2. Okay, now, since it bounces at -3, this has to be squared, and since it also bounces here, this has to be squared. Okay, so we haven't seen one like this yet, so this is a good problem. And then how do we solve for that a value? Well, I want to use my other point, which they gave me the point -2, 10. I want to stick in x is -2 and y is 10. That'll give me 10 equals my a value times -2, plus 3. Let's change this to a plus, squared. I probably could have done this part in our head, but I started to write -2 already. -2 minus 2 squared. So 10 equals our a value times -2 plus 3 is 1 squared times -4 squared. So let's see, -4 squared is 16. 1 squared is 1. 16 times 1 times a is 16a. Okay, and then divide both sides by 16. And we get a equals, reduce that, we get 5/8. Okay. All right, and then next we want to stick that in here, and we'll have our equation, which is y equals 5/8. Make sure we're on the page here. 5/8 times x plus 3 squared times x minus 2 squared. Okay, so a lot like the 3.3a problems. Just be careful if it bounces. We need to make sure that our factor is squared. Okay. All right, almost done. A couple more problems here. Now these are going to start to look a little bit different, but we'll get through these one at a time. All right. Sketch the polynomial function containing the given points and write its equation. Okay. Write its equation is kind of like saying write the equation. Okay, so we want to do it exactly. Okay, so it's a quartic function we got all these intercepts. They gave us the x-intercepts and the y-intercept right here. Okay, so let's get a little sketch of that over here. All right, so we got intercepts at 3, 0. So I'm going to go 1, 2, 3. At 5, 0, 4, 5, -2, 0, and -7, 0. Over there somewhere. And then the y-intercept at 0, 0, positive 24, which is going to be somewhere up here. And again, I'm just going to label that. Okay. All right, it is a, oh, there it is. I knew I saw that, quartic function, okay, which means it's going to be to the fourth degree. And since there's 4 intercepts, I know that they each have to have a multiplicity of 1, which also means it's going to pass through at each of those points. So if I start up here at my y-intercept, it's going to pass through here and pass through there. So I know it's going to finish high, and it's going to pass through here and pass through there. So it's going to start high as well, so it's going to be high to high, okay, which is quartic, which is even, so good. It should either be high to high or low to low. And since it's high to high, I know my a value is going to be some positive number. Okay, so what's my equation going to look like? Well, it's going to be y equals some a value times, and then to get all these factors, I got to have x plus 5. I'm sorry, x plus, that's -7, so x plus 7, x plus 2, x minus 3, and x minus 5. And I know those are all to the first power because they all pass through. And then to solve for a, we just want to use this point, 0, 24. I want to stick in y is 24, and x is 0. So then I get 24 equals my a value times, and if we stick in x is 0, we're going to get 7 times 2 times -3 times -5. Okay? All right, let's see. -5 times -3 is positive 15. Times 2 is 30. times 7 would be 210. So then 24 equals 210 times A. Okay, and then next divide both sides by 210. And I get A equals, what's that, 24 over 210. I'm going to reduce that, make sure I do it correctly. So it'd be 12 over 105. 3 goes into both of those. 4, 35. So we're going kind of fast, but I think we get 4 over 35. Okay, which is some positive number, which is good. That's what we knew we would get. And then my final answer, just checking one thing. It's not on there. All right, so we get y equals our A value, 4/35, times my factors, x plus 7, x plus 2, x minus 3, and x minus 5. Okay, and then this big thing is our equation. All right, moving on, 2 more here. Okay, now this one's written a little bit different than what we've seen, so let's take a look at this one. It says sketch and write the equation of a 5th degree polynomial function with the following characteristics. It crosses the axis at -6, 3, and 5. So crosses means, passes through. And it touches the axis. So touches means it's kind of going to touch it and then bounce back off. Okay, so it's going to, in other words, bounce at -1. Also, h of 0 equals -9. So that's the y-intercept. Okay. All right, and then like it says, caution, it's a 5th degree, but there's only 4 x-intercepts. Well, that's because one of them bounces, so one of them is going to be squared. All right, so let's get our sketch first. Okay, so it crosses at -6, 3, and 5. So those are some of our x-intercepts. -6, +3, and +5. And then it touches at -1. So then I got those 4 intercepts. And we also have the point 0, -9. All right. So we can always start at the point that's not on the x-axis, and then I just need to know what it does at each of these points. So let's see, it's going to bounce here and go through the other ones. So let's get the bounce out of the way first. It's going to come up here, bounce, go back down, and come up and go through. And then it's got to go through here and go through here. All right, so we've got something that's high to low, which means it should be an odd degree, which, yeah, it's a 5th degree, so that's looking good. High to low, we already know that our A value should be some negative number. And then let's find that negative number. Okay, so first of all, what is our equation going to look like? Well, it's going to be y equals some A value times what factors? So let's see, to get an intercept at -6, we got to have x plus 6. To get one at -1, we got to have x plus 1, and since it bounces there, that one's going to be squared. And then at +3, we got to have x minus 3. +5, we got to have x minus 5. All right, so then now I just need to solve for my A value by using this point. So I want to stick in x is 0 and y is -9. And that's going to give me A times, if I stick in 0 in all these places, we get 6, 1 squared, -3, and -5. Okay, and then we just want to simplify that, so we get -9 equals, let's see, -5 times -3 is +15 times 1 squared, which is just 1, is still 15, and then times 6, we get, well, why am I having brain fart? So, sorry, 15 times 6, 90. Oops, sorry, 90A. Okay. All right, and then divide both sides by 90. And then reduce that, and we get A equals because negative over positive negative, and then 1/10. Okay, and then we can plug that into our equation, and we get y equals negative 1/10 times x plus 6 times x plus 1 squared times x minus 3 times x minus 5. And the order of your factors, and even technically the a value, doesn't matter. We're just kind of going from left to right with our intercepts. Okay, and there's our equation. Last one. I know this is kind of a long set of notes, but again, this is an important section, learning how to write these equations. So sketch the graph and write the equation of a cubic, so a third degree function, whose graph passes through these points and is tangent to the axis at 3, 0. Okay. All right, so let's get this drawing going first. All right, passes through at 1, 10. So 1, 10 is going to be somewhere up here. Negative 4, 0. Right there, and 3, 0. Okay, so it passes through this point, and is tangent here. Now, you hopefully remember from Math 2, tangent basically means it just touches it. So saying it's tangent to the x-axis is a fancy way of saying it bounces there. Okay, so I know it's got to come from this point down to here and bounce, so it's going to look something like that. So it's going to finish high, and then it's got to pass through this other point, so it's going to be low to high. Okay, low to high is good for a cubic function because it's either low to high or high to low. All right, let's see. What's our equation going to look like? Y equals some a value times what factors? Well, to get an x-intercept at negative 4, I got to have x plus 4. And it passes through, so it's to the first power. And then x minus 3. And since it bounces there, that one needs to be squared. Okay. Next, let's use the point 1, 10, which we did not label. Stick in y is 10 and x is 1, and we'll get our a value. So we get 10 equals a times 1 plus 4 is 5. 1 minus 3 is negative 2 squared. So let's see, negative 2 squared is positive 4 times 5 is 20. So we get 10 equals 20a. Divide both sides by 20. And we get a equals 1/2. Okay, and then positive 1/2, low to high, yeah, that looks good. So then I just need to plug that in, and we get y equals 1/2 times x plus 4 times x minus 3 squared. All right, so a lot of examples here, but hopefully this material is pretty clear now. Ask questions in class if you have them. That's it for Objective 3.